In this demo, we're going to take a look at conditions, which are similar to lock objects in that it allows you to guard specific sections of code, especially where processes have to work with each other. Unlike the simple lock structure, though, this one allows you to release the lock temporarily, notify anybody else waiting, and let them continue until they're done processing. And you can kind of take turns with this particular type of lock. Let's start with our configuration. And we're going to use a thread this time instead of a process. The biggest difference between a thread and a process with the debug statement is that it's not process name anymore, it's thread name. But as far as the debugging is concerned, the rest is the same. Notice we also imported condition from the threading module as well. So then let's go ahead and define our main routine. And the main routine should be defined in such a way that if we're in there, we're going to create a condition. We'll set it equal to a new condition object as such. And then we can spawn off our threads. Now, I'm only going to create a couple consumers and one producer thread here. So a lot of times we do multiple producer and a single consumer. We're going to change things up a little bit. So I'm going to create a consumer thread 1, and I'll set it equal to a new thread object. The name is going to be equal to consumer 1, and the target is consumer. Yes, we could still do this in a comprehension, but sometimes it's good to lay things out linearly like this so you can remember exactly what we're doing if we weren't using a comprehension. So we'll have two consumer threads, CS1, CS2. They're both going to fire or launch the consumer method. And then we're going to have another one called PD, which is going to be our producer thread. And then we'll say the name is producer this time. The target will also be producer. And finally, the args is going to be equal to, and we'll also send condition. Okay, so there's our three threads that we're creating. And we'll start the consumer first. Then we'll sleep some. Then we'll start the second consumer. Then we'll sleep some. Then we'll finally start the producer. Okay. Now, for this particular demo, we're not going to worry about a bunch of other synchronization stuff or waiting to join on these processes. We could. I just want to demonstrate how this condition works between the different threads. Okay, so we'll define the consumer first. And the consumer will accept the condition variable, which I conveniently named CV for condition variable. And let's do a debug statement here, and we'll say that the consumer, well, we know the consumer thread is going to be in there. It'll just say started. We'll know which one it is. And then we can use acquire and release like we do with a lock, or like with a lock, we can use context manager. So when it acquires it, the with will do the acquire for us, and when we exit the with, it'll do the release for us. Okay, but just because we are in there doesn't mean we actually have access to the resource yet. Okay, because we know the consumer will get it first because it's the first thread to start, but it's still going to be waiting right here. And the reason it's going to wait is because we need to release the resource from the producer. So we're able to get in here. We're able to get this far. We have acquired it. We have acquired the condition. But we are going to put ourselves in a wait state, waiting specifically for the producer to signal that it's ready for us to start consuming. So let's go ahead and put another debug statement in here, and then we will assume that after this happens, the consumer has consumed the resource. And that's really it for the consumer. Now, the producer is actually going to be very similar. And once again, it is going to indicate that it has started. And it is going to acquire the condition variable. And once it's acquired it, let's go ahead and put some debug statements. I'll just copy what I had up there for the consumer. And then we'll say making resources available. Let's see if I can spell it correctly. And instead of a wait, we're going to signal to everybody that they can feel free to use the resources. So then it'll be a notify all. So then they would consume the resources. Now, if this was in a loop, then what would happen is the consumers will consume all the resources and then acquire the condition variable again, and then get back into a wait state, waiting for the producer to once again notify all, saying that there is a resource available to consume. So let's save this, bring up a terminal. And we'll start Python with conditions demo. And hopefully, if I didn't forget anything, we will see that the consumer's waiting, the second consumer's waiting. Then as soon as that happens, the producer starts, makes the resources available, and then the consumer will consume the resource. And like I said, if this was happening in a loop, we could have it, for instance, the producer could, let's say, for, and then we'll, for, no, don't do it that way, for I in range, well, maybe not 10. Let's do 5. Okay, put the debug statement ahead. Okay, so then it will continually make resources available. And let's just also say when it acquires it, maybe it has to sleep a little bit. Let's just sleep 1. We don't know what's going on in there. And then we'll also put this in a loop. And we don't have to actually do it this way. Let's do a while, not white, while true. So we'll just let it continue forever and ever and always. And then if we want, we can have some other signaling technique, like possibly an event. So let's go ahead and add event here. And then we will create an event here in main. We'll call it the quit event. And now when we pass the condition, we'll also pass quit to all of them. And then let's go ahead and add quit as parameters to each of our threads. And then after it's done with the for loop, we'll have the producer set the event. That means it's going to signal for it to quit. And while true, if quit.isSet, return. And it will exit the thread. And we could actually say that here. Let's put a debug. Quitting. Notice here I don't actually have to say consumer waiting, because we know we're going to be in the consumer based on the thread name is called consumer. Okay, so let's see what we have here. We are creating an event. We pass the event to each of the different threads. And then the producer, when it's done producing, will set quit. And then we're monitoring the consumer to see if it should quit. So you can see, making the resource available, consumed, consumed, consumed. And then you can see the producer making resource available, make resource available, consume the resource, quitting, consume the resource, quitting. The one thing I didn't signal is the quit set. So let's add that. And we'll say done. So we'll actually see when this thing is done. Save it again. I'm going to run it again. So we should see all that happen nicely again. So the threads are starting. It's making the resource available. They get consumed. And then when it's done, the producer is now done. The consumer consumed the resource, quit. Consume the resource, quit. So you can see we can start using these different locking and synchronization techniques together to make a more robust program. So using conditions for locking or guarding resources is a slightly more sophisticated process than just using a simple lock. However, it does allow us to control, especially in the producer-consumer environment, when the producer is ready to release resources to the consumer. We have this signaling technique where we can acquire it using the condition variable wait. And then the signal from the producer, the notify all, tells any waiting consumers that they are free to go acquire the resource. We could also use this in conjunction with a queue. So when an item is placed into the queue, instead of constantly polling the queue to see whether or not there is data available, we can signal from the producer that it added something to the queue, and then all of the consumers can try to acquire that value. The good news is, because the queue will only give its value once, even if you have 10 consumers all vying for it at the same time, because they're all in the wait state, only one will get the resource, and they will basically return false on the fetch out of the queue, and then if it's in a loop, it'll just jump right back into the wait state, waiting for the producer to notify again that there is a new resource available.